Question 1. This setup below can be used to prepare oxygen gas. Study and answer the questions that follow. Now this takes us to preparation of gases. We do a few notes on the side to review. When dealing with questions that require you to answer questions on laboratory preparation of gases, remember the whole course, the whole curriculum of since Form 1 to Form 4, the secondary curriculum for chemistry, you cover several gases, about 19 if I'm not wrong. So these are the key points. Generation of the gas. How is the gas generated? How do you purify the gas? Once pure, how do you dry the gas? Drying the gas. And finally, gas collection, method of gas collection. These are the key points that you need to keep in mind. Like in our case here, to prepare oxygen, how do you generate the gas? There are the following reagents. There is action. If you use water, then the solid must be sodium peroxide. If you use hydrogen peroxide, then the other one must be manganese oxide. So this are for generation of the gas. So in our case we have sodium peroxide. So definitely X is water. And then once the reaction occurs in the chamber, we skip purification and drying. We go to gas collection. Method of gas collection here is over water. Why do we use over water? Oxygen is slightly soluble in water. Now we embark on the questions. Identify X. From our analysis, X is water. What property of oxygen makes it possible for it to be collected as shown above? Property of oxygen that makes it possible for it to be collected, so gas collection above, so here. And from our analysis up here, we have said oxygen is slightly soluble in water. Next, part C, state 2 uses of oxygen. Oxygen has several uses. We are going to give just a few of these, but if you refer to Form 1, air and combustion, where oxygen was dealt with in great detail, you will get to add on the list. So one is oxygen is used in hospitals by patients who have breathing difficulties. When mixed with when you mix this with acetylene, it can be used in welding. Oxygen is used by mountaineers and deep sea divers. deep sea divers. Just a moment. Divers. So those are the few uses, but ensure you can add on the list by referring to the topic air and combustion. Question 2. Write equations to show the effect of heat on each of the following. So here we need to write equations of decomposition. This decomposition is caused by heat, so it's called thermal decomposition. So we start with the first one. Sodium hydrogen carbonate. So the correct chemical formula is valency 1, carbonate valency 1, so we will have that. And so we'll write the formula correctly. This one is solid. Upon heating, it decomposes to give us the more stable sodium carbonate, water, and carbon 4 oxide. Ensure to write the chemical symbols because any missing chemical symbol can cause you a penalty of half a mark. Next, we need to balance our equation. If we place 2 before sodium hydrogen carbonate, it balances out here because this will be 2, carbons become 2, oxygen become 3, 1 here, and 2 here, so making it 6. You can check here 2 times this is 6, so the equation balances out very well. Silver nitrate. Silver, the chemical symbol is silver, written like that. And then nitrate, valency 1, valency 1. This gives us the chemical formula as silver nitrate. So silver nitrate, solid. We are heating. Upon heating, it decomposes to give us silver, nitrogen 4 oxide, and oxygen. Balancing this, place 2 here. This becomes 2 because of the oxygens. This becomes 2. The oxygens become 2 times 2 here. You can see that. 4, and here we have 2. So 2 times this is 6. And this side is 6. So balancing out very well. And finally, anhydrous iron 2 sulfate. Iron 2 sulfate. Hope that's it. Maybe we try it on the side. Iron 2 sulfate. This common, so simplified 1. And remain with the chemical formula as this, so this is correct. So heating forms iron 3 oxide solid plus a gas sulfur 4 oxide and another gas sulfur 6 oxide gas. It's very difficult to decompose iron 2 sulfate. In fact, requires very strong heating. We are placing a 2 before iron 2 sulfate on the reactant side, and that balances out our equations well.